Assalamualaikum. Welcome to part 5 for chapter 6 gravimetric analysis. So in this video I will explain about filtration, which is to separate the precipitate and washing, drying or igniting, and then weighing. So filtration and washing. So after precipitation we need to wash the precipitate. So the precipitate must be separate from supernatant solution and the constituent of the sample by using the filtration technique. So filtration is using filter paper. It's normally by using the filter paper. It's used to collect all the precipitate form. So this is the type of the filter paper. In the laboratory, there are filter paper grade number 42. There are filter paper grade number 41 and also the filter paper grade number 40. For the best is the filter paper grade number 40 for the medium size or crystalline precipitate. And for filter paper grade number 41 is suitable or is ideal for the coarse or gelatinous precipitate. And for grade paper number 42 is for the fine precipitate. For filtration and washing, so washing is required because the precipitating reagent is usually added in excess. So we need to wash the precipitate. Sometimes the reagent or the analyte is still attached to at the surface of the precipitate. So since the precipitate form is usually not 100% insoluble, therefore the great care is taken during washing, and do not wash the precipitate too long. If you wash the precipitate too long, what happens to the precipitate? Sometimes the precipitate can dissolve to become the solution. So many precipitate cannot be washed with pure water because peptization occur. Okay, so peptization is when the precipitate dissolve in the solution or precipitate become the analyte. So the best way is to wash the precipitate a few times, not wash once with total same volume of washing solution, which means better we wash with, for example, the total volume of 30. So we repeat the wash by using 10 ml for 3 times compared to 1 times for 30 ml. And for filtration and washing, so ideal washing liquid which is no solvent action on precipitate, dissolve the impurities only and easily dissolve the impurities, easily evaporate at drying temperature of precipitate, contain no substance that will interference with the subsequent determination of the filtrate. By general, pure water is ideally used. This is the example. A precipitate form of an analyte contains 1 gram of contaminant. So suppose after washing the precipitate with 50 ml of washing solution, the precipitate hold 1 ml of the washing solution. Compare how much contaminant remain in the precipitate after 1 washing, 50 ml or 5 times 10 ml each washing. So by using method A, if we use 50 ml washing solution, amount of contaminant remain in the precipitate is 0.02. So we try to compare. If we using 50 ml by method A, directly wash with 50 ml, and method B is we wash with 10 ml 5 times. Still the total 50 ml. So if we using 50 ml 1 time, so the amount of contaminant around 0.02. So if we using the method B by 5 times, for the first time after washing, the amount of contaminant, okay, the amount of contaminant remain in the precipitate is 0.1 gram, and after the second washing, we got the impurities is around 0.01, and therefore after 5 washing we got 0.00001 gram of contaminant. So it's better to do a washing many times with the same volume. For drying and ignition, after filtering, the gravimetric precipitate is heated until it will become constant. Okay, so drying usually be done by heating at 110 to 120 for 1 to 2 hours, and sometimes we need to leave the precipitate inside the oven for 1 day or for a night. Okay, heating remove the solvent, absorbed electrolyte, and any volatile species that is carried down with the precipitate. So some precipitate must be ignited to decompose the solid and form a compound of stable and non-composition. This new form is often called the wedging form. So wedging and the dry precipitate. The wedging form of the precipitate is weighed using the sensitive analytical balance method to calculate the amount of analyte in wedging form. There are two methods for calculation. I will explain in the last video, which is the chemical factor and also the gravimetric factor. So that's all for this video. Thank you.